Okay, continuing on. Previously, I thought about how to find the limit of a function on basically the methods of direct substitution. And basically, if that doesn't work, there are three other ways to try solving it. That is basically through factoring, trigonometric identities, as well as what's the other one? Reciprocation. No, not reciprocation. Rationalization. So one example to rationalization is this. Here we apply trigonometric identities, and here we applied factoring. Okay, so this time we will start on one-sided limits. So what does this mean? So these are basically it refers to the limit of a function as it approaches from either the left or the right. So in that sense, we have something called right-hand limit as well as left-hand limit. So for right-hand limit, so basically x approaches a from the right side. For the left-hand limit, x approaches a from the left side. In the number line, we all know that if this is 0, everything from the left is negative. So here approaches a from the left side, so that means negative. So from the negative side. And in the same sense, at the right side of the number line is positive. So coming from the right means coming from positive integers. So graphically, although I don't think there is much relevance in knowing this, personally from my experience, this is what a right-hand limit looks like. So this is A, this is your L. The curve basically is your f of x. So yeah, approaching from the right side. And in a similar sense, for the graph that refers to approaching from the left side, so that's what it looks like. So coming from the left, coming from D. Let's say if A is equal to 2, if we say x approaching from the right side, so A minus is going to be 1.99999. If we say A from the right side, or something that's greater than 2, let's say 2.0001. So that kind of logic, it's relevant to this concept of one-sided limits. Also, it is important to know that the limit exists if and only if the limit of f of x as x approaches a from the left side is equal to L, and the limit of f of x as x approaches a from the right side is also L. Basically, they are both equal to each other. So in a graph, it looks like this. So approaching from the left and approaching from the right, there is this in the middle. So how about sample problems? So let's say this one, x approaches 0 from the left side. So how do we solve for this? So one way is, well, we all know that the closest, or one of the closest values to 0 from the left side is negative 0.00001. And then don't forget the absolute value sign. And basically just copy the same thing below. And because this is absolute value in the numerator, that becomes a positive value, whatever's inside. And what's below, since there's no absolute value, you just You just copy its sign. And therefore, this one is negative 1. What about if you want to solve for the same thing, but this time x approaches 0 from the right side? So the closest number to 0 from the right side is, well, just 0.0001. It's the same thing as earlier, just positive. Below, it is also positive. Just copy the same thing. And you have both positive on the numerator and denominator. Therefore, you have positive 1. Since it is identified that these are not equal, so the limit does not exist. Granted that these two values are the same, supposedly the limit would exist, but in this case it doesn't. It's not like that. Okay, another example. These examples would possibly involve basically an application of what was taught in the previous vid. So it's relatively easy, so you don't have to worry. For here, for this question, we just have to direct substitute. We don't have to do anything fancy. So 4 raised to 2 is 16. 7 times 4 is 28. And then minus 16. Answer is 28. What about the limit of 70? By the way, I think we are applying the theorems on limits. So if you know your math, limit of c, or in other words a constant, is just the same thing. So the answer here would be 70. What about the limit of x minus 1 and then times open close parenthesis to x plus 9? So this is 2 minus 1 times 4 plus 9, 13. 13 is the answer. Easy, easy. Limit of x plus 5 over x minus 3 such that x approaches negative 2. That's going to be 3 over negative 5 or negative 3 over 5. Next. Of course, what I'm going to tell to you now is these kinds of questions won't appear in your typical college calculus test. But basically, this is what you learn in senior high school. You have to know these before you proceed to learning the next steps, which I'll be teaching in the next videos. Not necessarily steps. I think the better word for that is more complicated lessons. So okay. And then two raised to 4, that's 16, plus 4 plus 1, 4 plus 5 is 9, 21, this would do. What about x cubed minus 2x minus 4 over 2x cubed minus 3x minus 4 as x approaches positive 2. So 8 minus 4 over 2 cubed is 8, 16 minus 6 minus 4. Okay. So in the numerator, that's going to be 0. So you don't have to do the math below anymore, as long as it's not going to lead to 0 as well. 0 over 6, I believe. Yeah, 0 over 6, that's still equal to 0. Okay, we're done. Okay, we have more sample problems to answer, turns out. But don't expect direct substitution to be always the way to solve. So applying what has been learned in the previous video, hmm 9x, no, that's more like it. Just know how this works. That's a property in algebra. Nine plus 9, 18. Plus 88, that's 36. Zero is 9 minus 9. So you cannot direct substitute. What do you do? Let's try simplifying the numerator. So that's going to be 6x plus 9 minus 9. Okay, I know what to do. So further simplify, you'll get something like this. You want to cancel, so factor. So when you cancel the x, you'll have x plus 6 over 2. Then you start substituting directly. So 0 plus x is still 6. 6 divided by 2 is 3. That is your answer. Let me just... Okay, I am recording. Good thing. X squared plus 3x minus 4 as x approaches 1. 1 raised to 2 minus 1. Okay, that's clearly 0. 1 plus 3 minus 4, 0 over 0, so you cannot directly substitute. So let's try something at the numerator. Transform this into this. Below, let's see, factor, we'll have 4 and then minus 1. Cancel. It's going to be 1 plus 1, 2. 1 plus 4, that's 5. 2 over 5 is the answer. Next. So, x raised to 6, sorry, negative 1 raised to 6, this is an even numbered exponent, so it's just going to be positive 1. Even number, 2 is an even number, so that's still 1, negative 1, and then raised to 2. Assuming this is in parentheses, so this is different from this. That's my point. Plus 4 minus 5. 0 over 5 minus 5 is still 0 over 0, so you cannot directly substitute. So what do you do? Okay, so the challenging part here is, well, you have to know how to, for a while. Oh, okay. If factoring doesn't, if you don't like to factor, there's another way. Although you'd be extremely unlucky if you don't memorize the algebraic properties. I'm not sure if that's how you call it, but basically you know that if this is a raised to 3 minus b raised to 3, that's equal to, well, a minus b, a plus b times a plus b. You know that from a list of properties. So here, the exponent value is pretty high. So what do you do? There's another way of solving. This is through L'Hopital's rule. It's something that I'll be teaching in another video, but let me just show how it's done in this example. So clearly, from earlier, we've seen that if we directly substitute, we'd get 0 over 0. This is one of the indeterminate forms that tells us that if we get something that's this value, 0 over 0, then we could apply L'Hopital's rule appropriately. So with that in mind, basically let's find the derivative of the numerator and the denominator. So we're gonna have something like this. And then just directly substitute. That's it. As simple as that. So negative 6 over negative 6. No? Negative 2, negative 4. Okay. That is correct. Next. Okay, so clearly you cannot directly substitute. You can apply rationalization. So basically, like that, and then cancel the x. These two values would also cancel. So what is our x value? 0, right? So yeah, the answer is going to be this. What if you apply L'Hopital's rule here? Since clearly a while ago, we've seen that we have an indeterminate form if we directly substitute. So the square root function symbol could be rewritten as raised to 1/2. Okay. Once we apply derivative, so we bring down 1 over 2, and then we subtract it with 1, so that's going to be negative 1/2. Actually, since this one is just a constant, derivative of a constant is always going to be 0, so that's automatically 0. Derivative of x is just 1, so we have something like this. And when we substitute x as 0, by the way, since this is a negative exponent, we can reciprocate. Sorry, I keep saying that word. We can bring this down, basically, and the sign will change into a positive, and then we could rewrite it as a square root expression once again. So after substituting x as 0, we get this. So it's essentially the same answer as a while ago. Okay. One more. Okay. Rationalization. By the way, this is supposed to be plus. Whatever the sign here, write the opposite. Okay? I suggest that you don't simplify it, because as you can see, when we factor, this could be rewritten as that. And now it's clear that we have something to cancel. X approaches 1, right? So 1 raised to 2, 3, 3, 1, 1, 4 over 2, 2. The answer is 2. Okay? Okay. A few more. So as you can see, we have this sign. That means coming from the left. So clearly we cannot direct substitute. So find something to factor. Cancel. 1 over x minus 3. That's going to be negative 1 over 6. What about the limit as x approaches 2 from the right side? So in this case, we cannot really do much. Actually, let's try L'Hopital's. 0 over 1. Just so happens that the answer is positive infinity, not 0. Because usually this is supposed to be 0 already. Perhaps it's because of the coming from the right side idea that suggests or implies that the answer is positive infinity. Maybe. Okay. Clearly, we cannot directly substitute. So, let's try L'Hopital's. 1 over 2, 1 minus x raised to 3 raised to negative 2 times the derivative of what's inside the radical sign. So, that. And then okay, this is pretty chaotic. Give me a minute. Okay. And then cancel. What is our x? 1, right? 3 times 1, that's just 3. Here, it's gonna be 0. For some reason, the answer is positive infinity. When it comes to one-sided limits, I can't really explain much. This has also been my struggle in the exams. Okay. You know what? Let me just take a picture of my solution, then we'll move on. Okay, so after rationalizing, try to find something to factor, as shown here. And eventually, you'll have this. When you actually, what's shown here is that rationalization isn't always the easiest way. So that's why sometimes, from time to time, I use L'Hopital's because it's easier. As you can see here, with just a few solution steps, you're able to find the answer already. So, yeah. I'm eager to introduce you to the next lesson. There's a lot more, especially the spiciest ones, if you get what I mean. Okay, let me just take a picture. We'll have this in the next video.